This video we're going to be looking at the ear lab. So this is exercise 25 in your lab book. So if you would go ahead and open up your book to page 374, feel free to pause the video while you get to the right page. So when we look at figure 25.1, this is the anatomy of the ear. So we have the external ear, the middle ear, and the internal ear. And the structures, we're going to have the auricle or the pinna. And then we're going to have the external acoustic or auditory meatus or canal. Acoustic and auditory are interchangeable, so whichever one makes you happy. We have the tympanic membrane. We're going to have the malleus. The incus is behind it, and then we have the stapes. This opening is the eustachian tube. In your book, it's called the pharyngeal tympanic tube or the auditory tube. All three are interchangeable. The term eustachian is E-U-S-T-A-C-H-I-A-N tube, so eustachian tube. All three are acceptable. And within the inner ear, again, you're going to have the cochlea. You're going to have the semicircular canals. You're going to have the vestibule. And again, I'm not saying vegetable like a carrot. I'm saying vestibule like entranceway into, kind of like a foyer. So that structure there. And then you have the vestibular cochlear nerve. Okay. This is just kind of tilting that same picture so you can see the inner ear a little bit more efficiently. So again, we have the malleus that is attached to the tympanic membrane. We've got the incus, and we've got the stapes. We're going to have the cochlea. We have the vestibular cochlear nerve. We have the vestibule. Within the vestibule, we're going to have the saccule and the utricle. Figure 25.2 shows you the saccule and the utricle. And then we have the semicircular canals. Now we do have three of those. We're going to have the superior or anterior semicircular canal. They are used interchangeably, so superior or anterior. We have the posterior semicircular canal. It's the one at the back. And then we have the lateral semicircular canal. It's the only one that lays on its side. So getting a little bit closer to those structures, again, here is that tympanic membrane. So the front side, here is the back side of the tympanic membrane. Here is the malleus attached to it. There's the incus, and there is the stapes. Again, figure 25.2 shows you that inner ear structure. So we have the cochlea. This is where we're going to have hearing. We have the vestibule. This is where we're going to have the organs of static equilibrium, and you will have the utricle and the saccule within it. And then we have the semicircular canals. That is where we're going to have the organs of dynamic equilibrium. At the base of the semicircular canal, you're going to have this swelling. This swelling is called the ampulla. And again, this is the superior or anterior semicircular canal, the posterior semicircular canal in the back, and the lateral semicircular canal laying on its side. And this is the vestibular cochlear nerve. So tilting it or looking at it from the top, again, we can see the cochlea, the vestibule, the superior or anterior semicircular canal, the posterior semicircular canal, and the lateral semicircular canal. And here's the ampulla, the swollen area. We're going to have the cochlear branch of the vestibular cochlear nerve, and the part coming here is the vestibular branch from the vestibular cochlear nerve. Rotating it, again, we can see the stapes. Underneath the stapes is a structure called the oval window. The stapes is fused to the oval window, so that's why we can't see it very well, but underneath here is the oval window. And this is the round window. So whenever you are listening to the lecture about hearing, this is where we're going to push in to kickstart the compression waves within the inside of the cochlea. And this is where that compression wave comes out, kind of pops into the middle cavity, and then the decompression wave comes back that direction. And again, we can see the vestibular cochlear nerve, the cochlea, the round window, the oval window, the stapes, and the semicircular canals. We have the posterior semicircular canal, the lateral semicircular canal, and the superior semicircular canal. This structure is not in your lab book. Unfortunately, this is the otoscope. So the otoscope is what you use to look into the ear. So you use it to view the tympanic membrane. So otoscope, O-T-O, always means ear. and this one will allow us to see it on the inside. Okay. This is the slide of the cochlea, so figure 25.3 and 25.4. So this space here is the scala vestibuli. It is a part of the bony labyrinth, so it is going to be filled with our perilymph. We have, again, the cochlear duct here. This is a part of the membranous labyrinth, so it's going to have endolymph. And then we're going to have the scala tympani. The scala tympani is another part of the bony labyrinth, so it is going to be filled with perilymph. So the scala vestibuli with perilymph, the cochlear duct with endolymph, the scala tympani with perilymph. This is the vestibular membrane. It's the thinner one. This is the basilar membrane. It's the thicker one. And this is what's called the tectoral membrane. Now on the basilar membrane, we're going to have hair cells. So when we look at how we hear, and again, this is known as the organ of Corti, C-O-R-T-I. Your lab book says spiral organ. They are interchangeable. So the organ of Corti is the organ of hearing. So when we look at how we hear something, the compression wave pushes the perilymph of the scala vestibuli, presses the vestibular membrane into the cochlear duct that is filled with endolymph. And the endolymph here presses on the basilar membrane that pushes into the scala tympani, filled with perilymph. It pops back out the round window. And then on the decompression wave, the perilymph presses on the basilar membrane, pushes into the cochlear duct. This tectoral membrane slaps the hair cells, setting up a nerve transmission. And that's how we're going to hear. Now, figure 25.5, you can cross that out. It's basically what I kind of just described to you. So the picture can be beneficial to help you with lecture, but we are not going to worry about it for lab purposes. Activity 4 and 25.6, that's just showing you how to use a tuning fork for hearing. Again, unless you have a tuning fork at home, you can just ignore this part. Figure activity 5, ignore that. So now we're at figure 25.7. So this is going to be the crista ampularis, which is our organ of dynamic equilibrium. So our equilibrium while we are moving. So figure 25.7 and 25.8 is the slide in your book. So we're going to look basically at figure 25.7b. And we also have the close-up, which is what C looks like. So here we have the endolymph. Okay, so it's going to be a part of the membranous labyrinth. So the fluid is the endolymph. And this is going to be what's called the cupula. So that little marshmallow looking structure. A cupula is just a bump out. So if you see castles, they have cupulas. A bay window can be considered a cupula. It just kind of projects away from a surface. So this little cupula has jelly, and if you move, it sloshes the endolymph and it moves that jelly, that cupula, and buried within it are going to be hair cells, and that's going to allow us to pick up movement. This is just that close-up. So we have endolymph, we've got the cupula, we've got the little hair cells, okay. And this is going to be our organ of dynamic equilibrium. Figure 25.9 is showing you static equilibrium. We do not have a slide for static equilibrium. This is a good picture to help you with a visual for lecture, but I'm not going to ask you about the picture in lab. The only thing that we're going to care about for static equilibrium is I might ask you what is the organ of static equilibrium, and that would be the maculae or the macula. Again, macula is just Latin for spot, so that's the first bold word on page 382 is the macula, which is our organ of static equilibrium. Now activity 7, if you choose to do so, you can. At home, you just get in a chair and spin. We do care about the definition of nystagmus, which is the first bold word under activity 7. So this basically means that when you spin, with your eyes closed, if you stop and open your eyes will continue to twitch in the direction that you were spinning. This is seen a lot of times in cartoons. If you ever watch Bugs Bunny get dizzy and they stop and the eyes keep moving, your eyes will actually do that. They slowly kind of trail in the direction in which you were spinning. And that's known as nystagmus. It's part of the reflexes that help us with balance and equilibrium. So that would be a definition or a word question. And that is it for exercise 25.